Okay, now let's take a look on how to construct a confidence interval for a population mean that is unknown. Once again, what we'll be doing in this section is we'll be taking a sample statistic, and based off of that sample, we're going to create a plausible region where we believe the unknown population mean is located. Okay, once again, this is known as a confidence interval. Confidence interval, we need to find the lower bound, the upper bound, and then the mean with some confidence we believe is located somewhere in here. Okay, now the formula is in the handout. This is the formula to find the confidence interval. Notice here this lower number right here with the comma. This lower number is the lower bound once we calculate it. Likewise, the upper bound is here. That upper bound will be this part of the axis right here. Okay, so some conditions must hold just like before for normality to construct the confidence interval. So for normality, we have to assume that our sample size is less than 5% of the overall population size. We must also meet the normality criteria that the data was drawn from a population that was normal, and if it's unknown if the population was normal, the sample size has to be bigger than 30. Okay, and then the sample must be a random sample or sampled through a simple random sampling process. Okay. Once again, the margin of error E, that's going to be the latter part of the confidence interval formula. Notice if we go up here, T alpha over 2 multiplied by S over root n, that's going to be the error, where when you go from x bar on the axis to the bound, there's error there. The x bar to the bound here, likewise, we have some error there. Okay. So when we're asked to calculate sample size, notice how n is equal to, and it reverts back to z. Okay. And the reason why it reverts back to z is because z deals with large sample size, bigger than 30. So if we're looking to reduce a margin of error, typically we need a large sample size to do it, something bigger than 30. So t-distribution by the central limit theorem approaches the normal distribution, or z, so we revert back to the z alpha over 2. Now, I want to look at example 1 part A to show how to construct a confidence interval for the mean. Okay, so let's look at this example. A researcher wants to estimate the miles per gallon for a 2011 Ford Focus from a population. Once again, time consuming, very expensive to do. To take every single Ford Focus 2011 from the population, instead what we'll do is take a sample. Suppose 6 owners are randomly selected. The miles per gallon for their Ford Focus is recorded. And here we have some nice data with their miles per gallon. Construct a 95% confidence interval for the mean miles per gallon. Okay, so here we're going to assume that the normality conditions do hold. I want to show you how to calculate the confidence interval. Okay, so given a data, first thing we'll do in the calculator is plug it into L1. Okay, so that's going to go to stat, edit, and you're going to enter your data into L1. Okay, once you've entered your data into L1, go ahead and quit to the home screen. Okay, and I want to show you where to actually calculate the pieces for the formula. So if you wanted to do this by hand, the by hand approach requires x bar, s, n, and critical value t alpha over 2. So at least these pieces here, okay, we could find using a very nice calculator function we've been using all semester. The way we can find this is by using 1 var stats. Sometimes the problem will give you what these 3 things are, the 3 variables, but if they give you data instead, you can find these 3 values by doing one var stat. So let's go ahead and take a look. We'll go to stat, calc, one var stat, and we'll run a one var stat on L1. So notice we have X bar 36.53. We have sample standard deviation 3.345. And we have sample size is equal to 6. Okay. So going back to the formula, now we can find X bar. Now we can plug in. Now we can plug in for S. Now we can plug in for N. Now all we need to find is a critical value. Okay. Now in the previous video, we showed how to find the critical value just like the Z alpha over 2. So whenever we're looking for critical value, it'll follow the same behavior. So first, to find T alpha over 2, you first need to find alpha. Okay. And in this problem here, if we go down to part A, construct a 95% confidence interval. So alpha is the remaining 5%. But just like before, we're not just looking for alpha, we're looking for alpha divided by 2. So that's 0.05 divided by 2, 0.025. But again, we're not just looking for the alpha over 2, we're looking for the critical value, T alpha over 2, and there's two ways to do it. We can either use inverse T with area 0.025. Degrees of freedom, well, if sample size is 6, degrees of freedom is 5. Okay. That's going to find my missing T value, and just like before, always take the positive. You can also use the table approach to do so. Since I'm using the 83 here, I have to use the table approach in this case. So I'll go to 0.025, cross check with a degrees of freedom of 5. My value is 2.571. Okay, and take the positive sign. So now going back to the formula, we have all the pieces we need now to find that confidence interval. We have X bar, we have S, we have the sample size, and we also now have this T alpha over 2 in the lower and upper bound. But just like before, it can be very time consuming in calculating this by hand. Okay, so I do want to show everyone how to actually calculate this in the calculator using a very nice function that I'll show you now. The calculator function I want you to look for is called T interval. Okay, T interval. So let me show you where to find the T interval function. We'll go to stat, tests, and number 8, T interval. So whether you have the 83 or 84, everyone will have this calculator function. Okay, so let's go ahead and click on the interval and see what happens. By default, the input will be on data. So let me show you what the input means. Sometimes a problem won't give you the data. Okay, if you're looking to construct a confidence interval for a mean, sometimes it will not give you the data. It will actually give you the pieces that you need already to begin with, X bar, S, and N. So it won't be necessary to run a one var stat because it'll be given to you. And if that's the case, where those variables are given, your input will be stats, and you will enter those accordingly. If you were actually given data like we were in this problem, your input, you'll go to data, and you'll enter L1 or wherever you have your data into the list, leaving frequency by default at 1, and then you'll enter the confidence interval just like before in decimal form. Okay, so here we're asked to construct a 95% confidence interval for the mean. Let's call that 0.95. And notice what's going to happen. We're constructing that plausible region once again, where we believe with some confidence the unknown population mean for all 2011 Ford Focus should be within. So when we hit enter, okay, it'll take a little time to load here. So some things to consider. This data has an X bar or sample mean of 36.53. Based off of that sample, we're creating a 95% confidence interval. This value here, that's going to be the confidence interval bounds. And in the first line of the t-interval, that's your confidence interval. So between 33.023 miles per gallon and 40.043, we believe with 95% confidence that the unknown population mean is between the confidence interval 33.023 and 40.043. So to answer this question, our 95% confidence interval for the mean, we believe the mean mile per gallon is between 33.023 and 40.043.